Okay, so in the last video I had you try this problem on your own. And I did it a couple ways. There's probably about 6 other ways to do this problem, but I'm not going to do that. I showed a couple ways that most of y'all probably will do. Some of y'all might have chosen to eliminate x, and by doing so you'd multiply the bottom equation by -2, and it's over a little bit here, by -2, and then the top one you wouldn't change at all. And so by doing that you get y equals -1, and then you get 2 -1 as your solution. Now I put -1 into y, I put it on the top one, but you can put it in the bottom one. You'll still get 2 for your x value. Some of y'all might have looked at this equation or the system and said, I want to eliminate y, and by doing that you would end up with this type of system, and by multiplying top by 3 and the bottom by 5, you would eliminate y, and you get x that way. And notice how you get the same answer whether you eliminated x or you eliminated y. It doesn't matter. If you have any questions on that, let me know. But there's about 6 different ways to do this problem, and I just did 2, probably more common ways of doing it. Okay. Then before, we're going to solve our system by addition method. And notice how here, these terms are not even lined up, whereas before they were. What you want to do is you want to go ahead and line them up. And there's many ways to line them up, but here if I want to get the y on this side and get the x on this side, the system would now become 2x, let's do in black. It would become 2x minus 7y equals -17. So I just subtracted 7y from this side and moved it to this side and have -7x on this side. 7y I mean. Subtract 7y from both sides. Now here I want to get the 3x on this side, so I'm going to add 3x both sides, so I end up getting 3x. 5y is positive, that's going to equal 17. Okay, so now at this point you have to decide whether you want to eliminate x or eliminate y. If I want to eliminate x, that would multiply top one by -3 and the bottom one by 2. That would give me 6 and -6 up here. If I want to eliminate y, I would multiply top one by 5 and the bottom one by 7. Okay, so it doesn't matter what you do. I'm going to go ahead and eliminate x. So I'm going to go ahead and multiply by -3. Down here I'm going to multiply by 2. That gives me -6x plus 21y equals positive 51. And down here I would get 6x, and I would get plus 10y equals 34. Okay, now this will eliminate the x's. I get 31y equals 85. Okay, so now I divide both sides by 31, I get y equals 85 divided by 31, which is not a very nice number, so I leave that as 85 over 31. Now remember a second ago, or a couple minutes ago in the other video, I said, do all systems have a nice point of intersection? And the answer is no. Some points will be something ugly like 3/7, 9 over 7. You have a point that's not going to be, a nice point. So here's one example, example 4, where that y value, 85 divided by 31 is not a nice number. So I leave it as a fraction. Some people like change it to a mixed number. I don't think my math app likes that. I'm just kind of curious to what that is. That's about 2 and 23 over 31. I'll use my ABC button. I hit 85, ABC 31. I'll change it to a mixed fraction for me. But again, my math app probably wants this right here. Now I want to figure out what the x value is. I could take this y and put it back into here or here and then solve for x, but I really don't want to deal with a fraction. Most students don't. So I would do is I tell my students that you can take that original system to have 2x minus 7y equals -17 and 3x plus 5y equals 17. And this time I could go ahead and try to eliminate y and I'll get x. So I'll multiply top one by 5 and the bottom one by 7. That would give me 10x minus 35y equals -17 times 5 is -85. Down here I would get 21x plus 35y equals 17 times 7, which is 119. And now when I add these together, the y's will eliminate. So I get 31x equals negative 85 plus 119, 34. X equals 34 over 31. Or, if I hit 34, ABC 31, 1 and 3, 31. So the actual order pair where they intersect, and again, my math club I think likes the improper fraction. It's a very ugly order pair, but so if these two lines were to cross one another, or they do cross one another, it's going to be not a clean point. Okay, but there it is right there. Now if you want to check this in your calculator will check this very easily. If you type this in here and type this in here and use your ABC button, it'll give you the same thing on both sides. Same thing here. Put this right there, and this 85 over 31 right here, and you'll get both sides of the equation equaling one another. That's why I probably would want to check on the exam, because these are very ugly answers. Okay, I'm going to go ahead and solve this problem by addition method. And I'm going to warn you guys you can get some ugly answers. Okay, so go ahead and pause the video and then try it on your own. So I started by multiplying the top equation by -3 and the bottom one by 2. And you could also, if you wanted to, you could multiply the top one by 3 and the bottom one by -2. You'll still get the same y value. Your sign might be different, but in the end you'll get negative 11 over 17. And then here I tried to eliminate, or here I eliminated y. By doing that, I got x equals 60 over 17. And so my order pair, or the solution to the system, is 60 over 17, comma, negative 11 over 17. Again, I would check this on the exam. So you would plug in this x value into here, plug in this y value into here, and you get a true statement. Then you plug in this x value in here, and this y value into here, and you get a true statement on both sides. Okay. Up until now, all systems have had one solution, an order pair that works for both equations. We've always had, up until now, an order pair that works for both equations. A solution, or a system with no solution, is called an inconsistent solution. Or inconsistent system. So let's look at this equation. If you don't know that it has no solution, you'll just start the problem like you would normally start it. You won't know until you start working. Here's the equation, or here's the equation for the system. If I want to eliminate the x's, there are many ways to do it. I could multiply top by 3 and the bottom one by -2, because that will make this a 12x and make that a negative 12x. Or you can multiply the top one by 6 and the bottom by -4, and you'll get 24 and -24. There's many ways to do this problem. I like to find the smallest number, but again, if you don't see that 12 would be the number you want to make them both, then you can multiply the top one by 6 and the bottom by 4 and make one of them negative. Anyway, so I keep on doing this. Multiply the top one by 3, I get 12x plus 18y equals 36. And the bottom one by -2, I get negative 12x minus 18y equals negative 24. And what happens is something interesting. I tried to eliminate x, that's what I'm going to get. But notice how the y's also eliminate. So on the left-hand side, I get the value 0. So when I add the left-hand side of the equation, I get 0. When I add the right-hand side of the equation, I get 12. This is never true. When you get a statement and all the variables disappear and you get a statement that's never true, this means the system has no solution. How does that happen? Well, the lines are parallel. The lines never cross because they're parallel. That's what's going on here. So if you took the time to actually graph this on a Cartesian plane, that on a Cartesian plane, you see the lines would be parallel and never cross one another. So here's what you would actually see. So if you were to graph the equations, you'd see the first line would be right here, second line would be right here, and they never cross. A linear system with at least one solution is called a consistent system. If the lines coincide, that is, they are on top of one another. Then the equations in that linear system have infinitely many solutions. Represented by every point on either line. The equations in the system are called dependent. So again, you don't notice this. When you see a system, you won't know this until you start working. You're like, oh, something weird is happening. So say I want you to solve a system. Well, if I were to solve a system, it doesn't tell you how to solve it, but notice how one variable is already by itself. So I'd probably go back to the substitution method. If they were on top of one another, the terms were, then I'd probably use the elimination method. So I'm going to circle this, and I'm going to put that in for y here. I get 15x minus 5 times 3x minus 2 equals 10. I get 15x minus 15y plus 10 equals 10. Now on this side, this would equal 0, so 0 plus 10 would equal 10, and that's equal to 10. That's always true. Notice how my variable disappears. The x disappears right here. And I get a statement that's always true. This means that there are infinitely many solutions. By just saying that, that's not entirely the right answer, because yes, there are many solutions, but what are they? Any point on y equals 3x minus 2 or 15x minus 5y equals 10 is a solution to the system. Now in my math lab, to represent that, you're going to say the set of all x and y, the set of all ordered pairs, such that y equals 3x minus 2. So such that that ordered pair is on that line. Or you could write the set of all x and y such that 15x minus 5y equals 10. Just have to do one of these, one or the other. So to indicate that solution, you would do this or this. In the last problem, you would write no solution, or you might do this, that'd be no solution. Otherwise, you're going to have an ordered pair like we have right here. Okay. So on your own, go ahead and do part A and B. You're going to solve a system, and when you get done, you're going to check your answer by replaying the video. Okay, so part A, I end up multiplying the top equation by 2, because if I try to eliminate x, I get that to be 10x, and the bottom was negative 10x. I multiply top by 2, and the bottom one, no change. And we get a statement that's not true. 0 to equal 15 is never true, so there's no solution. The second one, when I substitute this value into here, I end up getting a statement that is always true. Negative 40 equals negative 40 is always true. And so you can either write this statement here or this statement here. That means any ordered pair on that line is going to work, or any ordered pair on that line can work. Really, these lines are on top of one another. Example 7. Here's a real life problem, and I think I'm going to run out of time. I've got a minute left, so I'll go ahead and do example 7 in the next video, and then that will be the end of this section. I think I only have those examples. Okay? So go ahead and stop the video, and then start the next part to finish this section.